In this video, we're going to cover 6 trigonometric ratios. The aims are: name the sides of the right-angled triangle, find the values of the 6 trigonometric ratios for the angle theta, find the missing side or angle of the right-angled triangle, and task to check your understanding. At the end of this video, I would like to check your understanding, so I prepared a task for you. Comment below your answers or questions about 6 trigonometric ratios. You will see this task again at the end of this video. Now let's name the sides of the right-angled triangle by opposite, adjacent, and hypotenuse. The opposite side of the 90 degrees, that will be the hypotenuse. The opposite of angle theta, that will be the opposite. And the third side will be the adjacent. So that's how we name the 3 sides of the right-angled triangle. Let's try another one. This green right-angled triangle, using your 90 degrees. Opposite of that will be the hypotenuse. And then the angle theta, opposite side of that will be the opposite. And the third side will be the adjacent. So that's how we name the side of the right-angled triangle, using the 90 degrees, the angle theta, and the remaining side will be the adjacent. Now we have here the 6 trigonometric ratios, starting with the sine theta is equal to opposite over the hypotenuse, cosine theta is equal to adjacent over the hypotenuse, tangent theta is equal to opposite over adjacent. We can also use the SO, CA, TOA to easily remember these 3 right here. The S stands for the sine, O stands for the opposite, H stands for the hypotenuse, C stands for the cosine, A stands for the adjacent, and the T stands for the tangent. Now, the inverse of these 3 trigonometric ratios are: cosecant theta is equal to hypotenuse over the opposite, secant theta is equal to opposite over the adjacent, and cotangent theta is equal to adjacent over opposite. Next, find the values of the 6 trigonometric ratios for the angle theta, but on this right-angled triangle, one side is missing, which is the hypotenuse side, since that is the opposite of the 90 degrees. And then the givens are the opposite, which is 15, and 8 will be the adjacent. Now to solve for the value of x, now since it is a right-angled triangle, so we can use the Pythagorean theorem to solve for the x, which is a square plus b square is equal to c square. Now x will be letter C, since that is the hypotenuse. Then a will be 8, and 15 will be your b. Now let's substitute. So that will be 8 square plus 15 square is equal to x square. Then let's solve. So 8 square is 64, plus 15 square is 225 is equal to x square. Now we can add 64 plus 225, that is 289 is equal to x square. And to remove the square, we have to square root both sides. And square root of 289 is 17 is equal to, here we can cancel out the square and the power of 2. So that is equal to x. So x is equal to 17. Now we can find the values of the 6 trigonometric ratios. For the sine theta is equal to opposite over the hypotenuse, and the value of the opposite is 15 over the hypotenuse of 17. So the sine theta is equal to 15 over 17. Then cosine theta is adjacent over the hypotenuse. Adjacent is 8 over the hypotenuse 17. Then the tangent theta is equal to opposite over the adjacent, and the opposite is 15 over the adjacent 8. Then for the inverse, cosecant theta, so we can just inverse 15 over 17, that will be 17 over 15. Then for the secant theta, that's the inverse of the cosine, so from 8 over 17 it becomes 17 over 8. Then cotangent, inverse of tangent, from 15 over 8 it becomes 8 over 15. So here are the 6 trigonometric ratios for this triangle. Now solve for x using trigonometric ratios. For our first triangle, the givens are 40 degrees. The x will be your hypotenuse, since that is the opposite of the 90 degrees. And the 7 will be your adjacent. Okay. Now let's write here the so, ka, towa. Now which of these three is with adjacent and hypotenuse? And that is the ka, or cosine is equal to adjacent over the hypotenuse. So let's use that. Cosine theta is equal to adjacent over the hypotenuse. Now let's substitute. So that will be cosine. Theta is represented by the angle, so that angle is 40 degrees. So that is cosine 40 degrees is equal to adjacent, and that is 7, over the hypotenuse, that is x. Now let's solve. So cross multiply, that will be x times cosine 40 is cosine, or x cosine 40 degrees is equal to 7. And then we have to divide both sides by cosine 40 degrees. So we can cancel this out. So x now is equal to, now here you need a calculator and type 7 divided by cosine 40 degrees. And the result will be 9.14 into 2 decimal place. So the value of x is equal to 9.14. Next, on our second right angle triangle, so solving for x, and the x here is an angle. Since that's our reference angle, opposite of that will be the opposite side. And this 8 will be your adjacent. Now, based from the given, we have opposite and adjacent. Which among these three of so, ka, and towa with adjacent and opposite? And that is the tangent. So that's how we choose which among these three we are going to use based from the given sides. Now let's write here. Tangent theta is equal to opposite over adjacent. Then let's substitute. That will be tangent x is equal to opposite, that is 10, over adjacent 8. So let's copy tangent x is equal to, then we can divide 10 divided by 8 is 1.25. Now, since this is an angle, using your calculator, you have to press the shift button and then followed up with tangent, so that it will look like x is equal to tangent to the power of -1 and 1.25. Afterwards, once you see this in your calculator, then press equal. So x now is equal to 51.34 into 2 decimal place. Now, since x is an angle, so it should be in degrees, and that is the value of our x, 51.34 degrees. It's now time to check your understanding. Pause the video and comment below your answers or questions about 6 trigonometric ratios. And remember, math is more than a procedure. It's a powerful habit of thinking.